We're asked to find the component form of vector v with initial point at -3, -5, 3, and terminal point at -2, -11, 1, and then we're asked to find the unit vector in the direction of vector v. To begin, let's take a look at vector v in space. Here we see a vector v in space with initial point -3, -5, 3, and terminal point -2, -11, 1. We now want to find vector v in component form, meaning if we graph vector v in component form, it would be the equivalent vector with the initial point at the origin. To find the x, y, and z components of vector v, we take the coordinates of the terminal point and subtract the corresponding coordinates of the initial point. Let's go ahead and label the initial point, point A, which is the point -3, -5, 3. Let's label the terminal point, point B, which is -2, -11, 1. This indicates for vector v in component form, the x component is -2 minus -3. The y component is -11 minus -5. And the z component is 1 minus 3. Simplifying, the x component of vector v is -2 plus 3, or positive 1. The y component is -11 plus 5, or -6. And the z component is 1 minus 3, which is -2. Now we have vector v in component form. For the next step, we're asked to determine the unit vector in the direction of vector v. This can also be referred to as normalizing vector v. To do this, we first find the magnitude or length of vector v, and then the unit vector in the direction of vector v is equal to 1 divided by the magnitude of vector v times vector v. So let's go ahead and find the magnitude of vector v, which is equal to the square root of the sum of the squares of the components of vector v. The magnitude of vector v is equal to the square root of the sum of 1 squared and -6 squared and -2 squared. Simplifying, we have the square root of the sum of 1, 36, and 4. The magnitude of vector v is equal to the square root of 41, which does not simplify. This indicates the unit vector in the direction of vector v, which we'll call vector u, is equal to 1 divided by the square root of 41 times vector v, which is the vector with an x component of 1, a y component of -6, and a z component of -2. Performing the scalar multiplication, the unit vector in the direction of vector v has an x component of 1 divided by the square root of 41, a y component of -6 divided by the square root of 41, and a z component of -2 divided by the square root of 41. Before we go, let's go back to our graph. To begin, this green vector is vector v, plotted in space with the initial point at the origin. The blue and green vectors are equivalent, and then this red vector is the unit vector that we found in the same direction as vector v. I hope you found this helpful.